In this session, we're going to introduce a third kind of external measures called pairwise measures. What are pairwise measures? That means we take any 2 points, we see whether they agree between their class label and the partition label. So there are 4 possible cases for any pairs. We have true positive, false negative, false positive, and true negative. Then we look at the cases. For example, you get any 2 points x sub I and x sub j. If they belong to the same partition T and they also in the same cluster C, in that case, this is a true positive. For example, we look at this case, the definition is the true positive is the number of such cases. Okay. For example, for any 2 points x sub I and x sub j, if they have the same true partition label and they also have the same cluster label, that means they belong to the same cluster, then that's the case of true positive. For example, we just look at this case. For these 2 blue points, they belong to the same ground truth T2, and also they belong to the same cluster C2. That's true positive. Okay. Then what is false negative? False negative means they have the same ground truth partition label, but on the other hand, they are not in the same cluster. For example, you just look at these 2 brown points. They have the same ground truth T1, but they belong to different clusters. So that's the false negative case. Then what is false positive? False positive means they actually have different partition label, but they are in the same cluster. For example, you just look at this blue one and this brown one. They actually do not have the same partition label, but they are in the same cluster. Okay. What is true negative? True negative pairs actually means they do not have the same partition label, but they are also not in the same cluster. For example, you look at this black one and this blue one. These 2 points, they do not have the same partition label, but they are also not in the same clusters. So that's a good case. Then we see how we can calculate the 4 measures. First, given n points in the data sets, the possible pairs you need to examine, actually n chooses 2, so that's the reason you have this formula. Then for the true positive case, is you get all the partitions and the clusters. If they agree each other, that's the case. You have Nij, you choose any, these cases you choose any 2, you get that many cases. Okay. Then what is false negative? False negative means you get that many partition cases, but they do not belong to the true positive. Okay. What is false positive? That means you have so many clustering cases, but they do not belong to the true positive. Then what is true negative cases? That means for all the cases, they do not belong to any one of the above 3 cases, then they are true negative. Okay, so that computation, we can just simply use those formulas. With the introduction of true, positive, false, negative, these 4 measures, then we can calculate the other measures like a Jacob coefficient, rand statistic. Then we still take this figure as our illustrative example. Then for Jacob coefficient, remember we defined Jacob coefficient before, but this one is the definition for the pairwise measures. And this Jacob coefficient have the similar kind of flavor. You probably can see you have true positive divided by all the cases except that you ignore the true negative case. Okay. That means the fraction of the true positive points, but after ignoring the true negative cases. Therefore, this computation, positive and negative, are different. They are asymmetric measure. However, for perfect clustering, Jacob coefficient should be 1 because all the cases you actually covered. You don't have those false cases. For rand statistic, is you take all the true cases, true positive plus true negative, divide by all the possible pairs. Okay. That means you don't cover anything like a negative. Okay, that's why if it's perfect clustering, rand statistic should be 1. It is symmetric because you take a positive and negative case just equally. Then there's another interesting measure called Fox-Mallow measure. This measure is a geometric mean of precision and a recall. Remember, we just studied F measure, which is a harmonic mean of precision and a recall. For geometric mean, Fox-Mallow measure essentially is precision times recall, you get their square root. Okay. And once we introduce all these measures, if we want to calculate, for example, any table like this one, the screen table, we can use this measure to calculate all the numbers. We will leave this calculation as an exercise instead of spending time lecturing here.